Recording.
Hello everyone. My name is Srivallabha KM and I am currently pursuing my bachelor's degree in computer science and application at the Bangalore Institute of Technology. Today I am delighted to present on the topic of performance measurement in the, digital design and computer applications. And in this digital era where technology advances at an unprecedented pace, understanding and optimizing performance in digital design and computer applications are paramount. Whether we are developing software, designing hardware, or managing complex systems, the efficiency and effectiveness of our solutions profoundly impact our user experience, operation costs, and overall success. Welcome to the topic of performance measurement. And at the first, we will talk about performance measurements. And before perform, we need to understand about the performance, and then later on we can carry about the processor clock, basic performance equation, clock rate, compiler, and at the end conclusion, etc. Now performance measurements. Performance matrices are a measure to evaluate computer design. First of all, it is imperative to know the matrix. The most likely parameters of real world performance matrix are, as you know, about speed, capacity, cost, and energy consumptions. Due to this, the performance may vary and measurements may vary. The world evaluates these four factors with relevance to a target application or the requirement and chooses the computer. As I said about the main thing on the to choose the computer is that these are the four, the speed, capacity, cost, and energy consumption. The trade-off is amongst these four factors of these four. The speed is the performance of CPU. If the CPU performance is faster, the faster the work will be completed, or any task is or the process will be executed. Capacity is relevant to disk and or memory storage, and according to this, the speed is the main factor for the performance of the CPU. Now let's go and move to the next slide. Performance. To know about performance measurements, we need to know about performance. The most important measure of a computer is how quickly it can execute programs. What is performance? The more the how quickly it can execute programs. In computer, we check the programs or the process, anything that execute faster is, it has more uh, it has more ability to the task easily. uh, Three factors affect the performance are hardware design, instruction set, and the compiler. These are the main three factors. It's important. You need to note it down. For best performance, it is necessary to design the compiler, the machine instruction set, and the hardware in a coordinated way. The factors affect performance are these three: the hardware design, instruction set, and the compiler. We need to, if we want to get a uh, good performance or the best performance, it is necessary to design the compiler, the machine instruction set, and the hardware in a coordinated way in our convenient manner, where the performance is good. The like we should see about it. And if we come to the real world scenario, an organization planning to acquire a computer freezes the specification in terms of its expectations related to the applications. Then the options are weighed and evaluated. A common man may not detail his requirement as much as the shelf systems generally exceed his requirements in terms of capability, and hence cost might be the main criteria. In this chapter, we discuss the performance regarding the design of computers. If the cost is high, if in terms of capability, the requirements are high, then the cost is also high, then the performance is, as all we know, the performance will be good, but the output will not be as expected, because not many will choose it, because not everyone will be rich as the used to be. And we discussed the performance regarding the design of computers. The processor and a relatively small cache memory can be fabricated on a single integrated circuit chip. Uh, the processor and the small cache memory chip is both are in a chip, single integrated circuit chip, where speed, cost, and memory management are important. Then, if we move on to the next slide, a program will be executed faster if the movement of instruction and data between the main memory and the process is minimized. When in a computer, a process or a program will be executed faster than the usual if the movement of instruction and data between the main memory and the processor is minimized. The data between the main memory and the processor is minimized, the program will be executed faster than the usual, which is achieved by the cache. It's the the once again the working of cache is that it minimize the data between the main memory and the processor, where a program can execute faster than the usual. A number of instructions are executed repeatedly over a short period of time. As you know, the processor time to execute a program depends on the hardware involved in the execution of individual machine and instructions. The processor time, the time required to execute a program, that is called as processor time. It depends on the hardware, the processor, sorry, the processor hardware involved in the execution of individual. Each machine has its individual execution time, where the hardware is involved, and the processor time to execute will depend on the individual, yeah, on the execution of individual machine instruction. According to this, we all know that each machine has its own execution time, because the hardware involved depends on it. So the processor time is the different for different machines or the computers. This is the main memory, and this is the cache memory and processor. Both forms the processor cache. This is the main memory, and this is the cache memory, and this is the bus. Both adding to is bus. The processor cache, this is the processor cache. Whole this is known as processor cache. Next, flow of program instruction and data between the memory and the processor is as follows. At the start of the execution, all program instructions and the required data are stored in the main memory. The program instruction and the data are stored in the main memory. As execution proceeds, instructions are fetched one by one over the bus in the processor, and a copy is placed in the cache. If the same instruction or data item is needed second time, it is read directly from the cache. The the instruction, the flow of program instruction and data between the memory and the processor. At the start of the execution, during the execution time, all the program instruction and the required data is stored in the main memory. At the start of execution, the instruction and all the data will be stored in the main memory. As the execution proceeds, it starts, instruction are fetched one by one over the bus into the processor. All the each instruction is fetched one by one over the bus into the processor. Okay, and a copy is placed in the cache. All the instructions are fetched by the bus into the processor. A copy of that will be placed in the cache, as the cache stores the each copy of the instruction which is in the processor. And if the same instruction or data item is needed second time, it is read directly from the cache. If the same data or instruction is needed to be work on the processor, the cache will directly read, it will be directly read from the cache. That's all. The what its cache is a smaller memory, where the in processor, which holds all the data and instructions. Cache is also has the copy of the processor. Sorry, copy of the instruction or the data fetched to the processor is also made a copy in the cache. If the same instruction or data item is needed second time, it read directly from the cache. Next, if we move on to the next slide. uh, Performance of a computer depends on the constituent subsystem of the system, including software. Each of the second performance of a computer depends on the constituent subsystems of the system, including software. Each of the subsystems can be measured and tuned for performance. Thus, performance can be measured for CPU performance for specific application, vector processing, business application, etc. Instruction per second. Next, graphic performance, pixels per second rendering. Next, input output performance, transactions per second, and internet performance and more bandwidth utilization, Mbps or Gbps. Performance of the computer depends on the constituent subsystems of the system, including software. Each of the tuned for each subsystem will be measured and tuned for the performance of each of the like CPU. For CPU, different types of subsystem. For graphics, different, and input output different. For internet, different. There are four types. It's CPU performance, graphics, input output, and internet performance. For CPU, it's like for scientific application, vector processing, business application, etc. The number of instructions we give per second, like that. And for graphics, it's like pixels per second rendering. It's like frames per second, FPS. And in graphics, it's mainly for gaming, and also the number of pixels change per second, like that. And input output is like transactions per second. It's same as internet performance means the upload and the download speed, like it's in Mbps and Gbps. And if you move on to, it's same as it's not that important, because it's not like CPU graphics is easy, you can remember. Next, if you move on to the next slide, and this is system performance measurements. Uh, there are three metrics for any system performance measure, and these are performance, execution time, and throughput. In system performance measurements, performance, execution time, and throughput are the important three parts. Total time taken for execution of a program is equal to CPU time plus input output time, and others like queuing time, like it's in priority scheduling, or it will be like that same only. The This is important. Total time taken for execution of a program is equal to the CPU time plus input output time, and the others like queuing time. Okay. Generally, time taken to execute a program, maybe a standard program, any program, the time taken to execute a program is a thumb measure for system performance. This is called execution time. What is execution time? Time taken to execute a program is a thumb measure for system. Execution time means time taken to execute a program. Okay. This is an important formula. Performance is equal to 1 divided by execution time, or it can be made into execution time equal to 1 divided by performance. Throughput is the measure of work done in a unit time. Throughput, this is the third part. Throughput is the measure of work done, means in according to performance, the number of task or work we give for the processor, how much it will be done in a certain amount of time. The throughput is the measure of work done in a unit of time. Work means here task. Task can be considered. The given task will complete in a certain amount of time. That unit of time, how much task or work will be done, that will be measured by the throughput. It's important. And then comes the processor clock. Processor circuits are controlled by a timing signal called clock. These are the naming terms. This is important. In processor clock, the processor circuits are controlled by a timing signal called clock. The clock defines a regular time intervals called clock cycles. The execution of each instruction is divided into several steps, each of which completes in one clock cycle. The length P of one clock cycle is an important parameter that affects processor performance. Its inverse is clock rate R is equal to 1 by P, which is measured in hertz cycles per second. Here, processor clock performance circuits are controlled by a timing signal. Process circuits are controlled by a timing signal called clock. Next, clock defines a regular time interval. The regular time intervals is defined by the clock are called clock cycles. Each cycle has its own regular time intervals, and here execution of each instruction is divided into several steps. The instruction given to the processor during the execution is divided into several steps, each of which completes in one clock. One clock cycles completes one step of the instruction given by the processor at the time of execution. This is called one clock cycle. uh, Clock, as you know, that you should remember it correctly, because it's important. Clock, you should not confuse clock. Processor circuits are the circuits of the processor are controlled by the timing signal. It's called clock. And regular time intervals which a clock defines is called clock cycles. And here its execution of each instruction is divided into several steps. Each step completes in each of which completes in one clock cycle. And then the length P of one clock cycle is an important parameter that affects processor performance. P of one clock cycle is an important that affects one clock cycle affects the processor performance. The length, the which is considered here. Next, its inverse is R is equal to 1 by P. R here, R is clock rate. 1 by P. P is the length of one clock cycle. And here R is inversely proportional to P. As the length of one clock cycle increases, and the clock cycles will be the clock rate will be decreased. Here the clock rate is measured in hertz or hertz per second or cycles per second. Yeah, it's same as that what we have done in the previous class. Same. Basic performance equation. Processor clock is over. Basic performance equation. The basic performance equation is given by T is equal to N into S by R, where T is the processor time required. It's a T is time. The processor time required to execute a program that has been prepared in high level language. The program which is once again, processor time required to execute a program. The time required to execute a program which that has been prepared in which is in high level language. Here T is a time required to execute a program which has been prepared in high level language. The N is number of actual machine language instructions needed to complete the execution. In the previous we here once again in the previous we execution of each instruction is divided into several steps. Yeah, here number of actual machine language instruction needed to complete the execution. The instruction is given by the processor. The number of actual machine language instructions needed to complete the execution. The how many instruction should be given to complete the execution is called it's in the numbers or the loop. Next, S is the average number of basic steps needed to execute one machine instruction. Average number of basic steps. The each step completes, as we know, each step completes in one clock cycle. The average number of basic steps needed to execute one machine instruction means the how many steps are needed to execute one instruction. As we know, each step has its own each instruction which is given, and the average number of basic steps needed to execute one machine instruction. It's also same as the one clock cycle. Here S is you can simply say as the clock cycle itself, and R is the clock rate. In the previous we have seen it clock rate R is equal to 1 by P. It's measured in hertz. 1 by P is the length of one clock cycle. As the rate increases and the length, as the length of one clock cycle increases, the rate is also rate is decreased. T is equal to N into S by R. This is an important formula. You should remember it. And then if we come to the next slide, to achieve high performance. So if you want to achieve high performance, it's here. Reduce the value of T. Reduce the value of T, which means reducing N and S and increasing R. T is equal to N into S by R. N and S is on the numerator and R is on the denominator. For increasing, reduce the value of T, which means reducing N. If we reduce the value of T, N and S will be reduced and R will be increased. The value of N is reduced if the source program is compiled into fewer machine instructions. According to the formula, T is equal to N into S by R. Here, if the clock rate increases, the performance is also increased. So we want to reduce the T here, the processor time, where NS is also decreased, where R is increased. Next, reduce to achieve, for the high performance, we have to reduce the value of T. N and S will be reduced and the R will be, R is the clock rate, R is increased. The value of N is reduced if the source program is compiled into fewer machine instructions. The value of N is reduced if the source program is compiled into fewer machines. Okay. The value of S is reduced if the instruction to reduce the value of N and S, it's this is given. The source program is compiled into fewer machine instructions. The whole program should be compiled and made into simple instructions. The value of S is reduced if instructions have smaller number of basic steps. The if the source program if source program is compiled into fewer machine instructions, the value of N will be reduced, and the number of basic steps to perform the instructions, the value S will be reduced. See, the value of S is reduced if instructions have a smaller number of basic steps to perform, or if the execution of instructions overlapped. It will be of both steps. The basic steps should be smaller, or the execution of the instruction should be overlapped. Using a higher frequency clock increase the value of R. As the value of R increases, higher performance will also be increased. As the if you want to get the if you want to increase the value of R, the high frequency clock should be used, which means that the time required to complete a basic execution step is reduced. Next, the performance measurement. Here, where T is difficult to compute, measure computer performance using benchmark programs. Running a series of well-defined tests on PC to measure its performance. The performance measurements is based on it, to measure it using the benchmark programs. It's like running a series of well-defined tests on PC to measure its performance. It's same as that. Same as that. To evaluate performance of real application program, a non-profit organization called System Performance Evaluation Corporation, its SPEC, selects to evaluate performance of real application program. It's if any application or a program need to evaluate its performance, there is an organization called the SPEC, System Performance Evaluation Corporation, which selects or publishes representative application programs for different application domains, together with test results for many commercially available computers. For any computers, this SPEC, System Performance Evaluation Corporation, publishes the, if anyone publishes their application, or it will only publishes the application programs for different applications and together with the test results for the computers. By that we can check the performance of the computer. Like it's same as the measuring the performance. It's this you should remember this system performance evaluation corporation. This is the organization. And then next Uh, the program selected range for game playing, compiler, database application to astrophysics and quantum chemistry application. The application programs are game playing, compiler, database applications, and database applications, astrophysics, and quantum chemistry. These are the programs where the SPEC will give the test results for the different applications for the given computers. Sorry, for the available computers. Next, compile and run the selected program on the computer under test. The same program is also compiled and run on reference computer. How the SPC will test the benchmarks, yeah, give the performance measurements. They will compile and run the selected program on the computer, on the one separate computer, and the same program is also compiled and run on the reference. They have their own reference computer, or the and compile and run the selected program on the computer under test, which is the given computer of the which under test, like the which the performance is to be checked, or yeah, same that only. SPC rating, same I have said. The SPC rating is given by running time on the reference computer, the what the computer they have, and divided by running time on the computer under test, the performance which need to be checked. SPC rating is equal to pi I to the power n 1 to n SPEC. Yeah, SPC rating same I to the whole to the power 1 by 1, 1 by n. This is the important formula to check the SPC rating. By SPC rating, we can know the benchmarks. Benchmark is required to know the performance of the performance measurement. Yeah, by that we can measure the performance of any computer. Benchmark, which is very important. Then clock rate. How to increase the clock rate, improve the integrated circuit or IC technology to make the logical circuits faster. Yeah, clock rate can be increased by improving the IC technology, integrated circuit, which like OR and they are the ICs, to make the logical circuits faster, reduce the amount of processing done in one basic step. However, this may increase the number of basic steps needed. Increase in R that are entirely caused by improvements in IC technology affect all aspects of the processor's operation equally except the time to access the main memory. It increases in R, clock rate increases in R that are entirely caused by improvements in IC technology affect all aspects of the processor's operation equally except the time to access the main memory. Then compiler. A compiler translates what is the main function of the compiler? It translates a high level language program into a sequence of machine instructions. Yeah, if any given language, the program, if the program in any language, it converts or translates into machine level language. To reduce n, we need a suitable machine instruction set and a compiler that makes good use of it. Our goal is to reduce the n into s, where if ns is reduced, t is also reduced, the clock rate will be increased, r will be increased, by that performance is also increased. Here the main goal of our is to increase the performance. A compiler translates a high level, yeah, this is the definition of a compiler. And to reduce n, we need a suitable machine instruction set and a compiler that makes good use of it. A compiler may not be designed for a specific processor. It means that each compiler is not designed for a specific processor. However, a high quality compiler is usually designed for a specific processor. Not every compiler is designed for a specific processor. If the compiler is of good quality, or like it can translate any language into a machine language, if it's perfectly for a specific processor, then it can be used. Next, in conclusion, these are the use of performance measurements. In conclusion, performance measurement in digital design and computer organization offers a transformative approach to assessing and enhancing organizational effectiveness by integrating digital tools and computational principles. Businesses can achieve the following key benefits. Which are the key benefits? Real-time insights, efficiency and automation, scalability and flexibility, security and privacy, continuous improvement, innovation, and the last two, predictive analytics, employee engagement. These are the benefits. Let's see one by one. First one is the real-time insights. Digital dashboards and automated data collection provide a real-time insights into key performance indicators, enabling organizations to make timely decisions and report swiftly to changing condition. They should make timely decisions and respond to changing condition. This is the real-time insights. They should need to report the performance of the given computer in the real time. Next, efficiency and automation. Automation of data collection, analysis, and reporting processes streamlines performance measurement activities, reducing manual effort and improving efficiency. This allows employees to focus on value-added tasks and innovation. Automation of data collection, analysis, and reporting processes streamlines. Efficient automation means uh, when if the how the processor works, if there are any if it's efficient, or they can be automated by a person, or like that. This allows the employees have the focus to the task and innovation by improving the efficiency. Next, if we go on to the third one, scalability and flexibility. Cloud computing platforms offer scalability and flexibility, allowing organizations to adapt performance measurement system to changing needs, and scale resources are required without significant upfront investment in infrastructure. Next, security and privacy. It's cyber security measures protect sensitive performance data and unauthorized access and cyber threats, ensuring data integrity and maintaining stakeholder trust. Like it protect the privacy and the data which which the user has. By that, it shows security and privacy. Next, continuous improvement. Feedback mechanisms and benchmarking tools facilitate continuous improvement by identifying areas for enhancement and aligning performance goals with industry standards and best practices. Continuous improvement means the benchmarks, if the computers benchmark is checked correctly, so checked oftenly, then there will be an increase or decrease in the benchmarks. They can see the particular area where the benchmark is increased or decreased, but where the benchmark increase, they can implement this on the other processes too. If there is a significant decrease in the benchmarks, then they can see where something wrong is going on, or something else. Innovation, simulation, and modeling software enable organizations to explore innovative strategies and test hypotheses without risking operational disruptions, fostering a culture of experimentation and innovation. The next is predictive analytics. Leveraging machine learning and predictive analytics enables organization to forecast future performance trends and anticipate potential challenges, facilitating proactive decision making and strategic planning. Employment engagement. Digital feedback mechanisms empower employees to contribute insights, ideas for improving performance, fostering a culture of transparency, collaboration, and accountability. If the feedback should be given on each processor, each performance of the benchmark is tested. When the benchmark is tested, if it was tested by a, or any innovation is done by a particular employee, the feedback should be given by the user or the company heads, so that they can get some hike in their salary or something, uh, any collaboration or accountability. If we come to overall performance measurement in digital design and computer organization, it empowers organization to optimize performance, drive innovations, achieve sustainable growth in today's dynamic business environment by embracing digital transformation and leveraging computational tools, principles. Business can unlock new opportunities for success and competitive advantage. This is the performance measurements. If you want to let me take a glance, this is performance measurements. It's the introduction, and for knowing performance measurements, I need to know about the performance. The most important measure of a computer is how quickly it can execute a programs. That's how the performance is measured. Three factors: this hardware design, instruction set, and compiler. Next, if we move on to next slide, real world scenario, it's nothing important. Next, the cache is important here. A program will be executed faster if the movement of instructions and data between the main memory and the processor is minimized, which is achieved by the cache. Here cache play an important role. If every instruction or data stored in a processor is also copied by the cache. If a same program will be executed twice, then the processor need not to be executed second time. The cache memory directly will approve the processor. Processor time to execute a program depends on the hardware involved in the execution of individual machine instruction. Next, the same as what I just explained. Here the performance can be measured for like CPU performance, graphics performance, input output, and internet performance. CPU is for business application, a scientific application, etc. Graphics is for gaming, etc. Input output for transactions like anything, or transactions, yeah, etc. And internet performance like bandwidth utilization. System performance measurement here, total time taken for execution of a program, the CPU time plus input output time plus queuing time, it's important, and the performance equal to 1 divided by execution time. Next, processor clock. Yeah, these are the terms which is important: clock cycles, and one clock cycle. One clock cycle, the execution of each instruction is divided into several steps, each of which completes in one clock cycle. The length of one clock cycle is an important parameter that affects processor performance. R equal to 1 by P, where R is the clock rate and P is the length of one clock cycle. As P increases, clock rate decreases. Then this is the basic performance equation. It's important: T is equal to N into S divided by R. If T increases, NS increases, R decreases. If the clock rate decreases, performance also decreases. R and performance is directly proportional. And to if we want to increase the performance, our main goal is to decrease N into S, where if NS decreases, T is also decreases, R increases. Yeah, to achieve high performance, same what I explained. Then performance measurements, yeah, SPEC, it's an organization which it using benchmark programs, they test the application and give the test results for commercially available computers. SPC rating, it's a formula: running time on the reference computer, the computer they have, and the running time on the computer under test, the computer which is need to be tested. SPC rating, spec rating. Then clock rate. Yeah, it's the same. Then the it's how key benefits of performance measurements. Real-time insights, efficiency and automation, as I explained, scalability and flexibility, security and privacy, continuous improvement, innovation, and the predictive analytics, and employee engagement. Thank you for watching. This is all for now. This was a topic which needs to be explained today. Performance measurement. Thank you. Thank you for now.